Welcome. This is the Cisco CCNA3-ENSA, also known as the Enterprise Networking Security and Automation course. This course focuses on the CCNA version 7 curriculum. This is course 3 of 3. Module 7 is about WAN concepts. So in this video, we are looking at purposes, operations, and we're going to be looking at different types of WAN connectivity. So, first of all, what's the purpose of a WAN? Essentially, a WAN is a telecommunication network that spans a larger geographical area. Realistically, a WAN is a collection of LANs. We already know that one network cannot leave itself unless we're going through a layer 3 gateway. Well, those gateways are typically what builds our WANs. So we can look at a WAN as a network of networks per se. Normally the breakdown is LANs are small, WANs are larger geographical area. LANs are owned and managed by an organization, WANs typically are not. WANs are going to be managed by like an ISP, for example. WAN services are provided typically for a fee, where a LAN, again, it's managed and owned by an individual or by a smaller company, so there's typically no fees associated with that LAN. LANs definitely have a much higher bandwidth availability because it's dealing with local resources. WAN offer both low to high speed connectivity. It really all depends on what you're willing to pay for. So there are two main types of WANs: private WANs and public WANs. A private WAN is a connection that is dedicated to a single customer. A private WAN could be a guaranteed service agreement using an SLA. It will also ensure consistent bandwidth, no fluctuation, and it does provide a little bit better security. A public WAN connection is typically provided by an ISP or other telecom service provider, and they use the internet, for example. In this case, the service level agreement and the bandwidth will vary depending on the shared connection, and it's not guaranteed secure, and it's not guaranteed always available. So with the private WAN, an ISP could be the provider of the private WAN. It's not so common anymore, but I know 90s and early 2000s, ISPs would actually provide the infrastructure for a private WAN connection. However, with the exploding bandwidth of the internet, public WANs definitely have taken more precedence. We have a few different types of WAN topologies: point-to-point, hub and spoke, DualHome, full mesh, partial mesh. And don't worry, we have a breakdown of all of these. And again, these are not all of the WAN topologies. These are just the most common. So a point-to-point literally is a point through the network, through the internet, to another point. The layer 2 technology, that cloud, is irrelevant because between these two devices, logically, it views it as a straight point-to-point connection. With a hub and spoke, we could have a hub that leads to individual spokes. And again, we could also think of this as a semi-multi-point. It does enable a single interface on the hub router to be shared with all of these spoke circuits. So on the hub, we have one connection, and spoke A, B, and C all share that one hub connection. And again, the layer 2, that cloud technology, is irrelevant because the ISP is going to make it seem as if that cloud is completely transparent. We can have what's called a DualHome topology. This offers a greater redundancy, load balancing, and distributed connectivity. While this is more expensive and it is definitely more difficult to implement, they are the preferred method. They do require additional configuration, and there is a lot more complexity to that configuration. However, at least with this type of DualHome design, if one network goes down or one hub goes down, there's always the backup connectivity. We have our full mesh and our partial mesh. A full mesh, everything connected to everyone else. Our partial mesh is most things are connected to one another. And again, normally our partial mesh is just a small segment of our full mesh with at least all points being able to connect to one another for the most part. All of these basically go over through a carrier connection. So another aspect of WAN design is how the organization connects to the internet. All of these connections assume that there is some form of internet connectivity. Normally with that internet, we'll have to have some form of service level agreement with the service provider. The service provider will provide the SLA that outlines the scope and the expected service, reliability, availability of the service and connections. That way they know exactly what they're paying for. If you want greater reliability, you end up paying more for it. If you're okay with 8 hours of downtime a year, then that's what you pay for. If you need it down to 1 hour of downtime, then again, it's going to probably be an additional cost. The service provider may or may not be the actual carrier. The carrier will own and maintain the physical connections and the equipment between the customer and the provider. There is no guarantee that the provider and the carrier are the same individuals, because oftentimes the carriers may actually be a third-party company that lease their infrastructure to other providers. So single carrier connection is when an organization connects to that one service provider. Again, there will be an SLA that will be negotiated between the two that guarantees the certain level of site. We have a dual carrier, and that's where our connectivity is going through two different ISPs. That way, if one ISP goes down, we have a backup ISP. That way, we still have redundancy in our network design. All of this goes along with the idea known as evolving networks. So the issue is our networks are designed to grow and to scale. So normally there shouldn't be drastic changes in growth. However, sometimes there is. So when you're designing the network, there has to be that growth concept in mind. So the network must be able to meet the day-to-day operations and have a certain level of growth to the organization. The network designer and administrator needs to meet these challenges by looking at what's currently available, the budget, and what the business should be doing in the next 5 or 10 years. Lastly, the network can be optimized by using a variety of design techniques and looking at current and future architecture designs of the network. Cisco outlines the proper way to design a network, and they outline each of the steps to future-proof it, thus ensuring that your network will be able to survive even in the future. To illustrate the differences between the network sizes, we can also use a fictitious company. They're going to call the Span Engineering, and as it grows from a small local business into a global enterprise. And we're going to see that throughout the next several slides. So here, originally, it will be a small office with very few employees. It has a modem with a broadband connectivity to the network. It's a small LAN using DSL. And then it grows into more of a campus network, or a CAN, with its own building, with multiple floors, with multiple networks. And it's funny that they use 3 separate routers instead of like a layer 3 switch. But I mean, again, Span has grown through a facility, and now they are looking at having its own building or campus network. As Span grows, we may actually have to have multiple offices and multiple locations. So we can have a internet WAN that meets our interconnectivity connections, and we have multiple branch offices that will connect through the internet to allow for connectivity between our central office and all of our regional and branch offices. If we were talking distributing the network even larger, we could do the same thing through different WAN connections, and we can have them linked back using VPNs or a site-to-site VPN. We've discussed VPNs in a later chapter as well. So that gives us our understanding of how our networks are supposed to grow. So we actually have several different WAN operation standards. So the governing groups are things like IATIA, ISO, and IEEE. WAN technology normally operates at two different layers, layer 1 and layer 2. At layer 1, we're looking at things like SDH or SONET or some form of DWDM or wavelength multiplexing. Or we could be looking at different layer 2 technologies, broadband, wireless, Metro E, MPLS. Those are the big ones. HDLC, frame relay, ATM, those are all older legacy technology. Metro E, Ethernet, MPLS, those are the more common layer 2 WAN connections. Some terminology is extremely important when we're discussing our WAN. First of all, let me grab my pen. This guy right here, this junction box. This junction box, also called the demarc point, is the location, the physical location where the service provider comes in, and that is the end of their responsibility. So from that junction box back to the company, that's the service edge provider, SPE. From that junction box into the business, that is the enterprise edge. Sometimes it's also called the customer premise equipment edge. And that is actually going to make up the equipment that allows for the interconnectivity between the service provider and the enterprise network. We will have a few other pieces of equipment. We may have a DCE, and that's going to be a data communication equipment. That could be a switch. That could be some form of other equipment that's giving us our handoff. What I've seen in this location is I will see maybe a fiber line coming in. The fiber line will plug into the switch, and then the switch will transform that fiber connection into a Ethernet handoff, and they feed that Ethernet into the router. And in that example, the router would be known as the data terminal equipment. That is what will allow us connectivity to our LAN. So this would be to our LAN. On the service provider's side, this is known as the local loop. The connection between the demarc and the junction box in the neighborhood or in that area is also called the last mile, and it's typically about a mile or shorter. Those connections will go back to some type of central office, CO, and our CO will actually have a CO-based switch. From there, our central office will connect to their service provider to provide internet. So we talked about our demarc, we talked about our customer premise equipment, we talked about our DCE, we talked about our DTEs. What about this point of presence? Again, this is where the point where the subscriber network connects to the service provider. Our demarc is also sometimes called the POP, or point of presence. And we're not done with our terminologies. We've already talked about our local loop, also known as the last mile. We talked about the CO. So we also have things like our toll network. These are typically long haul backbones. These are typically WAN provider connections, and this is going to be normally a high bandwidth, and this will connect our COs back to the service provider. Our backhaul network, same thing. They may connect multiple COs. And our backbone network, again, a large high capacity network used to interconnect multiple service providers. That provides us enough of the terminology that we need to at least examine our different WAN technology. However, because we've also started talking about customers, we have to look at, we may have a voice modem, which is still legacy. We could have some type of DSL or cable modem, broadband. those are going to be our DTE type connections. If we are using a leased line, for example, we may have a CSU, DSU. Realistically, these aren't used as often anymore because leased lines are expensive and the bandwidth isn't really there. An optical converter could be something that will convert an optical cable to a copper cable. We've seen that in the previous slides as some form of DCE. And again, that's where we would take our optical cable and convert it to a copper-based cable, or vice versa. We could have some form of wireless connectivity, a wireless access point, a wireless network, a wireless connectivity for our WAN. It really depends. And lastly, we have our WAN core devices. This is going to be our layer 3 devices that run our core for our connectivity. And again, this is typically from the service provider's level. So this core is going to be the service provider, not the individual business provider. So that leads us into how we do our basic communication. Our communication normally is done one of two ways: serial or parallel. Serial is one connection, parallel is multiple connections. Almost all network communication is using a serial connection delivering. The serial connection will transmit bits sequentially over a single channel. Again, in contrast, parallel will simultaneously transmit several bits using multiple wires. As the cable length increases, the synchronization time between the different mediums or the different channels become more sensitive to the distance. That's for this reason parallel communication is very limited to short distances. Most things still use serial connectivity. Some of our older WAN technologies are things like our circuit switching. That's going to be our old telephone systems or our ISDN lines. This will use circuit switch networks. They will establish dedicated circuits or channels between our endpoints through the network and to the end device using circuit switch technology. However, modern day technology will use what's known as a packet switch communication or packet switch topology. And this can change. Each packet can actually go a different path. They will segment traffic into multiple packets and they will use a shared network. It's less expensive, way more flexible, and again, common types of the packet technology is going to be things like Metro E, MPLS, or older technologies like frame relay or ATMs. This is the common, more modern way of doing communication over WAN technology. Most ISPs will use some form of packet switching technology. So earlier we said our layer 1 technology is things like SDH or SUNET or some type of dense wavelength division multiplexing. That is where the layer 1 functionality comes into play. And this is normally when we're talking fiber, because SDH and our SONET are all fiber. Where dense wavelength division multiplexing, it's a newer technology that increases data carrying capacity of both SDH and SONET by simultaneously sending multiple streams of data, multiplexing the wavelength to send over one of their platforms. SDH is synchronous digital hierarchy. It's a global standard for transporting data over fiber optic. SONET, again, synchronous optical networks, and this is used in the US, and it provides the same service as SDH. And again, our DWDM is just a newer version of our SDH. Moving on, we have our traditional WAN connectivity. Those traditional WAN connectivities are going to be things like dedicated leased lines like T1, T3, or we may have a switched network, either circuit or packet switched. Again, legacy are going to be like plain telephone services, ISDN, frame relay. This is all older technology. And this is when LANs appeared in the early 80s, early 90s. And what needed to happen was their networks needed to have a local connectivity to a service provider. And they needed dedicated leased lines. And so this was the traditional way to provide connectivity. Now keep in mind, a T1 is 1.54 megabits per second synchronous, up and down. Realistically, that's not feasible anymore. You can this was also like $800, $900 a month. That doesn't really fly anymore when you can have broadband technology that is 100 times the speed or 300 times the speed for a third of the costs. So again, there's pros and cons for some of this older technology. Lease lines are available in different fixed capacities. A T1 is 1.544. A T3 is a bundled set of T1s, and you can have that up to 43.7 megabits per second. European carriers use the E series, and that's going to be 2.048 megabits or a 34.368 megabits. However, some of the advantages, very simplistic, the quality was there and the availability was guaranteed. Again, negative is the cost, and it is not very flexible. With our circuit switch options, again, PSTN based networks are our plain old dial-up or old technology phone services, and they were 56K. We had our integrated service digital networks, ISDNs, and again, this was built off our 56K, and this was providing speeds of up to 2 megabits per second. These kind of went away early 2000s. Packet switching technology in our early network designs were frame relay and ATM. Frame relay is a simple layer 2 non-broadcast multi-access network, where with ATM this was an asynchronous transferred mode, and this used cells instead of packets, and they did fixed length cells of up to 53 bytes per cell. So again, very low speed, but these are a legacy and these worked. So we ended up replacing a lot of these with more modern day connectivities. And that's going to be things like fiber optic is one of the big ones. Because essentially now we may have our different clients connect either through coax, through phone, through fiber, through wireless, cellular, satellite. It doesn't matter anymore. Our internet will take all of the connectivity types and allow across the board connectivity. So our modern WAN connectivity are broken into 3 main categories: dedicated, switch, or internet. If we're talking internet, that's normally some form of broadband VPN. If we are talking wired, that's going to be like DSL, cable, fiber to home, fiber to business. If we're talking broadband VPN, but we're talking wireless, it could be like a WiMAX, cellular, LTE or 5G, satellite-based internet, or some type of MAN-type Wi-Fi. If those are not what the individual is looking for, maybe they want some form of dedicated connectivity, that'd be like a dark fiber. If that doesn't quite work, then we have a switched network design, and that's going to be packet switching, and that'll either be Ethernet, Metro Ethernet, or MPLS. These are all different types of modern day WAN connectivity that allows for our connectivity. Dark fiber is easily going to be one of the growing areas, and that can be purchased or leased from different suppliers, and essentially it's just long distance fiber. So we talked about our Ethernet WANs, Metro Ethernet, MPLS, but we also have things like VPN or virtual private LAN services, VPLSs. So all of these provide different forms of connectivity, and the benefits of these are going to be reduced expense and administration, easy integration to existing networks because it's all Ethernet based, and it does allow for enhanced business productivity. It's cheaper, essentially. With MPLS, that's multi-protocol label switching, and basically this is high performance switching by our service providers. So the service provider WAN routing technology will interconnect clients regardless of their access method or payload. MPLS will actually I'm going to grab my pen. So you'll see here CE and PE. Client's edge, provider's edge. So it doesn't matter how you connect to the provider. Internally to the provider, it's normally some form of MPLS type internal cloud. Our MPLS cloud from the service provider will take all types of encapsulation from the inside, and it will handle its routing internally to the MPLS cloud. So here's an MPLS cloud. Here's our internet cloud. And the MPLS router will basically label switch routers using LSRs. They attach a label to packets that are then used by other MPLS routers to forward traffic. And this is done fast. MPLS normally is classified as a layer 2 technology dealing with layer 2 switching. That's why it will be high performance switching using labels. So we have a few other types of WAN connectivity, and that's going to be internet-based connectivities. And you're going to notice we kind of already talked about this with modern day tech. However, it can also be its own category using VPN technologies. Again, wired is a DSL, cable, that'd be copper coax or some form of fiber optic. Our wireless is some form of WiMAX, satellite, cellular being like LTE or 5G, and some type of man-based Wi-Fi. Our DSL technology normally is called, DSL is a digital subscriber line. It's a high-speed, always-on, and normally will use a form of DSL. A common form of DSL is ADSL or asymmetric DSL. Though DSL does come in other flavors, so we can have SDSL also. ADSL provides higher downstream, and it doesn't provide the best upload, but I mean it can. SDSL provides the same capacity in both directions, up and down. ADSL, they shrink the downstream so you can have more, they shrink the upload so you can have more downstream. Again, that's for ADSL. If we're talking SDSL, our up and down would be identical. So how does DSL work? Essentially, DSL will connect through phone lines, and you will have a DSL modem, and you'll have a phone line back to your central office. This is known as the last mile. My writing with my mouse kind of sucks. Last mile. Through phone line. Once you get to the central office, there's what's called a DSLAM, or DSL amplitude modulation. And it will modulate the signals to go out either the PSTN network or to the internet. And normally, at this point, when it's going back to the internet, the CO is connected to some form of high-speed backbone to get faster connectivity. DSL is not a shared medium. Each user will have its own separate direct connection between the DSL modem and the DSLAM. So this is one connection. So if there are 25 houses in a neighborhood, there needs to be at least 25 connections on the DSLAM. Older DSL used the PPP, or point-to-point protocol. Now it may be the point-to-point over Ethernet protocol. And it did require DSL to have a sign-on packet. So PPP was used to authenticate the subscribers using DSL. PPP was also used to assign addresses to the subscriber. There are two types of PPP over Ethernet. That is host-based or router-based. So if you had a router the router would authenticate, and the router would be allowed on the internet. That means anything behind the router would be allowed connection. With host-based, each host had to authenticate to be allowed on the internet. Old technology that is still in existence but definitely is dying. Cable technology is probably by far a little bit better and is definitely growing. Cable will use a cable modem. It will use coax line back to a junction box in your neighborhood. This again is called the last mile. The junction box will change from coax to optical. The junction box will send an optical signal back to the cable's quarters. So sometimes the coax will also be terminated into what's called a CMTS. That's a cable modem termination system, and that's normally located at some form of head office. The fiber medium enables the signal to travel over greater distances, long distances, because coax is not made to travel that far. The head-end container will have the database needed to provide internet access, while the CMTS is responsible for the communication aspect back to the cable modems. And we also have our fiber to home options. So some of those fiber to home options are things like fiber to home, fiber to building, fiber to the neighborhood. Fiber to the facility is definitely growing a lot faster. More build-outs are starting to use the fiber to the curb or fiber to home type build-outs. They may also do fiber to the curb and then do a curb to the inside house using coax, and sometimes those are still classified as fiber to the node or fiber to the neighborhood. Other forms of our internet-based connectivity are, again, municipal wireless, again, man-based wireless, cellular using 3G, 4G, 5G, LTE, other broadband cellular technology. We have our satellite. We also have our WiMAX. Again, WiMAX is going to be using our 802.16. That's high-speed broadband using wireless signals. All of this helps to build our VPN-based technologies. VPNs provide cost savings, security, scalability, and is pretty much compliant with any layer 2 or layer 1 based technology. Two main types of VPNs, site-to-site and remote access. Site-to-site allows us to set up a virtual tunnel between two devices through the internet and encrypting the data flow between those two devices. A remote access typically allows like a roaming user to connect to a static location, even though the mobile user's address may be changing. They will still encrypt data flow between the remote person and the static address. Our ISP connectivity, we've looked at this before. Single home, dual home, multi-home, dual multi-home. Our basic single home is point-to-point connection between our business, our home, and one ISP. We could have two connections between us and our ISP. We could have one connection between our ISP and we could have a backup ISP, or we could have two links to an ISP and two links to a backup ISP. It really just depends on how resilient you want to be and how much you're willing to pay. So earlier I kept saying the word broadband. Broadband actually is a massive solution that looks at both cable and DSL. So when we're talking broadband, we need to be able to compare some of our options. So some of our options when looking at our broadband technology are things like cable is going to be using coax and it's a shared medium. Oftentimes the cable provider does oversubscription. Basically, they put more people on the cable than it's made to handle, assuming that not everyone will be using their entire service all of the time. They over-allocate. DSL, limited bandwidth, limited distance, and typically is slower. Fiber to the home requires fiber installation, and that's becoming more common. Cellular or mobile broadband is based off of cellular signal. If you're in an area that has poor cellular reception, that won't work for you. Our man-based Wi-Fi, you're kind of stuck where there is some form of metro wireless or some form of WiMAX that's been deployed in your area. It really just depends on what's available. Satellite is the expensive option, but it also provides limited capacity per subscribers. This normally only is happening when this is the only option. I don't believe that this is the lab title for this lab, but we do have a lab investigating broadband and looking at broadband options. And that is all I had for this chapter. We looked at different types of WAN concepts, so we have a lab covering WAN concepts. We discussed what WAN is. We looked at WAN topologies, WAN standards. We broke down WAN technology in both layer 1 and layer 2. We looked at some of the wireless. We looked at some of the fiber-based wireless technologies, SDH and SONET. We looked at some of the packet and some of the circuit switching technologies. We looked at some of the modern day circuit switching based off of packet switching, modern day packet switching technologies, looking at like MPLS, Metro E, and other broadband technology. We looked at some of the wireless technologies, things like WiMAX, and we ended with more VPN conversations and ISP-based connectivity. That's all I had for this chapter. If you have any questions, please reach out. If you have any questions or anything, please feel free to reach out. Again, with this material, being able to ask questions and discuss some of the topics in the lecture help build long-term retention, so do not be afraid to communicate with this topic. Again, I'm here if you need anything. Thank you.